Hi, welcome to the introductory PSSE activities. So, today I am going to demonstrate how to create a case in PSSE and how to add the basic elements there. So, the first step in adding a case is to go through file option, then new, and then going to case data. Yeah, one have to select the base MB of the case, which is 100 in my case, and the base frequency. The unit for transformer ratings is expressed in MVA, and the unit for ratings for non-transformer branches also expressed in MVA. So we're going forward, clicking OK, and the case is created. Now, what I feel is that creation of cases is much easier if we create it through a slider diagram. So, what is a slider diagram? A slider diagram is basically uh, a pictorial description of the elements you create for the case, and somehow the database created inside the slider diagram gets linked with the network data, which is this Excel kind of database. So, what do we need for creating a case? First of all, we need some buses, which are substations, and then we need some connecting lines between the substations. Now, in that buses, there may be some kind of generator, some kind of load, there may be some kind of transformers, or there can be some bus reactors. So, adding the first bus. So before creating the bus, we are just ensuring whether that whatever we do inside the diagram is getting linked with the network database or not. So for that, we need to ensure that this bind items is always checked. So if it is checked, whatever change is being done in the diagram is being reflected in the network data or case also. So this is the symbol. This is sizable horizontal bus bar. So I'm creating this case. So each bus has got to have a number. So say suppose it is number one, and the bus name is say suppose A, and there is also a area owner and zone of the number. So for the present case, we are assuming all to be one. When we have multiple like different areas, then this need to be reclassified. So suppose this is a load kind of bus. So there are options of generator bus, non-gen bus, swing bus, or disconnected. Disconnected basically means it is not connected to anything. Swing bus is same as slack bus, the bus which is used to absorb all or inject all the imbalances in order to solve a power flow case. Generator bus is basically a PV bus, and non-gen bus is a PQ bus or load bus. So we need to specify the base kV. So how much, what is the voltage of the bus? So let it be 400 kV. Okay. So we are creating it. So each bus has got a color associated with it. This color coding is seen in this way. There is, for a particular voltage level, there is a specified color coding. For example, from 230 to 500, this is the color, which is almost kind of blue. So we have to create another bus. So suppose this is that bus. This is also again 400 kV. This is a bus number 101. Sorry, that is 400 kV bus. The bus name is B. The same area again. We are creating another bus. So we are actually going to create this bus on a lower voltage kV. So let it be 220 kV bus. This is again an on-gen bus. We are naming it as C. So when there is a two bus of different voltages, we can connect it with a transformer. So this is a symbol for the transformer. This is a two winding transformer. So we are connecting one dot here at A and another dot at C. When you are doing it, we are getting asked that what is the percentage reactance and percentage resistance of this transformer. There is a percentage impedance, so we are specifying this as 12.5%, so 0.125, and R is specified as 0. We have to give a rating of the transformer. Suppose this is a uh, mm, 315 MVA transformer. Okay, so this is, we are keeping the rating as same, but in actual case we can keep the overload rating at 10% higher. So we are keeping it, say, 345. So this is a short term overload rating. So this is created. Now we are creating one line that is between A and B substation. So for this is a symbol. There is a branch option being shown. So this is the line. Now for line, you again need to specify the rating. Say the first rating is around the like surge impedance rating. So it is, say, around 50 MVA. The next rating is 84 MVA, and suppose the line, we are actually mentioning a resistance and reactances per unit. So suppose this is the 0.0025 is the reactance rating, and point zero point zero zero two is the R rating. Suppose we also need to specify a kilometer for the line. So say this is 20 kilometer line, and this is the charging susceptance or the capacitance of the line. So this is point zero zero, say, 0.002 again. Okay. uh, when there is a provision of line reactor in the line, we need to specify this line G, line B, line also. So this is basically a conductance, and our line reactor is basically reflected in the line B. So there is two options. There is from line B or to line B. So in the from line B, say suppose from substation A. So if it is, say suppose it is a 70 80 imber bus reactor. So this 80 imber bus reactor is in rated for 400 kV. It is rated for 420 kV. So for 400 kV, it may be around 72 imber absorption. So we are specifying it as 0.72. So this is a line reactor. So this is, there is a message that branch is no longer treated as a zero impedance line. Next, we can create another bus. So give a bus name and give a base KV. We can again connect it with a line. Now in this bus, we can uh, attach a generator. So this is the generator. Now what are the minimum data we need to specify for a generator? The P gen, how much it is generating. Then what is a P max? The maximum, say suppose the maximum is a 500 megawatt units. So say suppose 550 is a maximum, or 520 is a maximum generation. There has to be a reactive power limit also. There is Q max and Q min limit. So say this is the reactive Q limit. So which is around uh, 200 mvar, and there is a minimum reactive power limit which is 200 mbar. This is a reactor. This is a 200 mbar. This is a minimum. There is a generation on the maximum absorption the generator can do. Now there is a minimum turbine limit, so there is specified as P mean. So suppose this is 55% for the unit, so it is around 260 megawatt, or around say 50%, 260 megawatt. So we need to specify the embase of the generator, which is the total machine capacity in MVA. So let it be like 550 MVA. Okay. Also for a generator, we need to specify the R source and X source. So X source is basically equal to the subtransient reactance of the generator. So let it be 0.18 or 18%. Also the generator, if you are like I am trying to model the generator transformer also. So maybe the generator is connected to a lower voltage, and there's a transformer which is stepping it up to the, say suppose 400 kV level. So we need to specify the transformer impedance also. So let it be zero point 0.2, and there is a scheduled voltage. The generator, since it's a PV bus, it is maintaining a voltage on some kind of bus. So for it, it is the bus on which the generator is connected. So as you can see, the bus number is 301, and the scheduled voltage it's trying to maintain is 1 per unit. Now there has to be some load also. So we are connecting one load in bus C, number 201. So we are creating that load with, say suppose 50 megawatt, and we are keeping it, say some reactive power also for the load. So let it be 20 mvar. So generally, as per the power factor, we will keep some kind of reactive uh, mvar also of the load. Now, for solution of any power flow case, we need one slack bus, and that slack bus has to be a generator. So we are creating B as one of that slack bus. Okay, so we can also specify some kind of turbine, some kind of generator generation limits over there. But as of now, we are not keeping it anything. Say suppose the embase of the unit is 500 megawatt. Now, what the slack bus will do when we run the whole power flow, the slack bus will give whatever, say, line losses or whatever deficit in generation to provide the uh, load, that will be given by the slack bus. If there is no help required, then it will not uh, give any such support. It will just say whatever the balance is there, but like after catering the load, after like there is an equation formed between the, there is a generation should be equivalent to the load and losses. So whatever balance is there, was whatever residual things is given, that is provided by the slack bus. So we are solving this power flow. So what is it, how we can we do that? This is a solution from power flow, and then solve. There is an option of like fixed slope decoupled Newton Raphson, full Newton Raphson. So and like applying the var limit. So we are solving it. So that what it is telling, that four buses are without any swing bus. So we need to assign a swing bus first of all. So how can we assign the swing bus? I am just changing the type code of the bus to swing bus. So this is PV bus. So this is also a generator bus, bus 301. So this is a load bus, and again B and C are load buses. A is slack bus, and bus ER is a generator bus. So we are again solving the case. So this is solved. You see the swing bus summary showing. So uh, swing bus is generating around 50 generation, so which is almost equivalent to the load. So why it is so? Because we have not provided any generation, that is P, for the PV bus. So in a PV bus, we know that P and V is to be specified. We have specified the voltage, but we have not specified any generation. So we are say we are giving 30 megawatt generation here. So We're giving 30 megawatt generation. We are again solving the case. So now you see that the slack bus is having a generation of 20 megawatt. So remaining 30 is being provided by the PV bus. So what I've told earlier, that the role of the slack bus is to uh, give the residual or balance in a system, like whatever left after, so the generation minus load minus line losses is provided by the slack bus. So you can also see that the q gen is 98 megawatt. So why it is so? So 20 megawatt is being absorbed by the load. Some are getting absorbed as a line losses. Some may be like absorbed by the line reactor also, which is provided here. So this is the net load flow solved case. Now, as I have said earlier, that I have created this whole case in slider diagram. You will find the reflection of this in the network data also. So as you can see here, this is a buses in a network data with its specified voltages, the area numbers, the voltage after the solution of the load flow, the plants. So one is slack, one for slack bus in bus one, bus number one, and bus number another generation is bus number 301. There is a machine. These are the characteristics of the machine. There is pgen, pmax, pmin, qgen, and other factors, which is also found within the slider dialog box. This is the specification of the load. Only one bus has load, that is 201 here. This is the specification of the branches there. So there are basically within the branch there is an AC line. So from bus A to bus B and bus B to bus ER, there are two branches here. And if I want to see the two winding transformer, so from bus A to bus C there is a two winding transformer. So from bus A to bus C this is a transformer. So I think this is enough for one to create a basic case, few elements, and solve the power flow case. Now you may try with the above knowledge how to create a bus reactor. Okay, so try to create a bus reactor and like get it connected to bus B and again solve the power flow case. Thank you.